Do you know what complex numbers are and why they are important? Today, we're diving deep into the realm of complex numbers, a fascinating concept that has revolutionized mathematics and physics. Complex numbers are numbers that can be written in the form of a plus by, where a and b are real numbers, and I is the imaginary unit with the property that I squared equals -1. In terms of notation, a complex number, z, can be represented in three different ways. The standard form is z equals a plus by. The polar form is z equals r times the quantity cos theta plus I sine theta. And the exponential form, also known as Euler's formula, is z equals r times e to the power of I theta. Each complex number can be represented as a point or vector in the complex plane, also known as the Argand plane, with a horizontal axis for real numbers and a vertical axis for imaginary numbers. When it comes to operations with complex numbers, we have addition, subtraction, multiplication, and division. The rules for these operations are straightforward. For addition and subtraction, simply add or subtract the real and imaginary parts separately. For multiplication and division, it's a bit more involved, but still manageable. Now, how about converting between Cartesian and polar forms? For Cartesian to polar, we use the formula r equals the square root of a squared plus b squared, and theta equals the arctangent of b over a. For polar to Cartesian, we use a equals r times cos theta, and b equals r times sin theta. Finding the nth root of a complex number is also possible thanks to de Moivre's formula. In reality, the use of complex numbers is not common in our daily life. However, they are crucial in fields like quantum mechanics, electrodynamics, and electrical engineering for analyzing signals and systems. For practice, try solving these problems. 1. Calculate 3 plus 4i plus 2 minus 5i. 1. Find the polar form of 1 plus I. 1. Find the result of 1 plus I to the power of 8. 1. Find all the square roots of -16. 1. Show that the absolute value of e to the power of I theta equals 1 for every real number theta. 1. Find the cube roots of 8i. 1. Prove that every non-zero complex number has an inverse. 1. If z equals 2 times cos theta plus 2i times sin theta, calculate z to the power of 12 using Euler's formula. Remember, complex numbers are not as complex as they seem once you understand the concept. They open up a new dimension in the mathematical world, making the impossible possible. So, keep exploring and happy calculating.